Hello and welcome back. So today we'll be going over pyAPP, which is the Python package that interacts with APP. pyAPP is a file-based implementation of APP and allows you to read and write APP7 files from Python. Together with the command line interface, APP allows for automation of mission and point performance computations. Now, before I go any further though, I'm going to give you guys a few prerequisites to this video. So first is having Anaconda or some other Python editor and configuration manager already installed. We're going to use Anaconda, but you guys can use whichever one you prefer. Next is having the pyAPP7 installation files already on your machine. It doesn't really matter where they are, but you need to have them somewhere locally. Last and definitely not least is being somewhat familiar with Python. That being Python environments, syntax, package management, etc. Because I'm not really going to go into an incredible amount of detail if something is solely Python specific and has nothing to do with pyAPP or APP. So without further ado, let's go ahead and get started. So the first thing you want to do is open up a Windows command prompt as administrator, because that is where all the setup commands are going to be executed. So the first command is going to be conda create, and this is going to create a virtual environment with the name and Python version that you pass it. So in this case, we're naming it pyAPP, and the Python version is going to be 3.6. Go ahead and proceed through the installation, and then let it do its thing. So next we're going to activate the virtual environment, and to do this we're going to type in conda activate and then the virtual environment name. And notice when you do this, it's going to put your virtual environment name in parentheses on the left side of the command line. This just means that it is now active. Next, navigate to where your pyAPP7 files live, because we're going to go ahead and execute the setup.py script. And to do this, we're going to call python setup.py install, and this will begin the installation process of pyAPP7 and all of its necessary dependencies. As for IDEs, it is 100% personal preference. So if you can connect your virtual environment to your favorite flavor of IDE, then that is definitely okay. But since we're using Anaconda, I'm going to go ahead and install an environment-specific version of Spyder. And to do this, I'm going to execute conda install Spyder inside of an active Python environment. And now I have a environment-specific version of Spyder. I can just type in Spyder into the command prompt and open up a development environment for pyAPP. And now I can just import pyAPP7, and if it imports without error, then it has been installed successfully. So now we're going to use pyAPP to manipulate and run the mission file we created in tutorial 2. Remember back, the mission file was actually rather generic. It was a ground operation, takeoff, climb, cruise, and then a landing. And what we're going to do here is we're going to use pyAPP to change the altitude at which the aircraft is going to climb to. So to do that, the first thing we need to do is import pyAPP7. Then we need to define a path to our mission file, which for us it's going to be local. Then we're going to load that mission file into memory. We're going to set a new climb altitude. We're going to run the computation. We're going to retrieve the results of that computation, and then we'll go ahead and plot up the results. So let's go ahead and import pyAPP7, And from the pyAPP package, we're going to import the files module. We're going to use a couple of them, but files is the only one we need right now. And next you need to define an absolute path to your mission file. Since this is a file-based implementation of APP, we are going to be reading and writing files. That means we need to load the contents of our mission file into memory. Now, the files module provides us with a mission computation file class, which has a class method from file, which allows us to provide an absolute mission file path, and it's going to load in all of the data inside of our mission file. Now that we've loaded our mission file into memory, let's go ahead and set our new cruise altitude. There are two required steps. The first is finding the segment that you want to change. In this case, it's going to be segment number 3. And then last, of course, is assigning the new and or desired altitude to segment number 3. Now there's a slight catch with this, so depending on your background, you may cringe a little bit when I say the simplest way to access the correct segment is by hard coding the segment index into the script, in this case the number 3. Obviously, the choice to hard code or not is dependent upon your needs. While it is the most simple, it may not be the most elegant. So I'm going to go ahead and utilize another pyAPP 7 module to show you that you don't necessarily need to hard code these segment indices. So we're going to create a variable name called segNameList. And what we're going to do is we're going to reach into the mission file and we're going to create a list of the segment names. Now, this is going to require the pyAPP 7 database module. Before we use it, we're going to instantiate it. So DB is going to be our database class instance. And then inside our segNameList, we're going to go ahead and utilize that database module and use the getTextFromID class method. And we're going to put this in a loop because we're going to get every single segment out of the segment list. And the segment list is returned when you use the getSegmentList class method from the mission file class. And when we provide the segment index to the getTextFromID, it is going to return the name of the segment. And as you can see, when I run that line by itself, we get all of the names of our segments. So now we're going to find the climb index from that segment name list. And to do this, we'll just utilize normal Python and use the .index lookup for a list, and we're going to look for climb. And as you can see, when we run it, it's going to provide us with the index of 3. We're going to use this climb index and pass it to the getSegment method of the mission file class. And it's going to return to us a mission segment instance associated with the climb segment. This means we can now access the end values of the climb segment. Notice the .xx at the end of that line. This is because the end value 1 isn't actually a value like the name alludes to. It's actually an APP data type called nextReal. And per the documentation, nextReal is an APP data type that wraps a float and allows a user to specify a label, type of a variable, and indicate if the value is a limiter. So when you're trying to change the value of a segment, you're going to want to access the .xx because that is the float associated with that variable. Anything else in there can be changed, like the label or the real index, but if you're changing only the value, and keeping everything the same, you want to change .xx. And we're going to save off that initial altitude, but we'll also just run this line just to prove to you that it is, in fact, the 2500 that we set in the second tutorial. And to further prove to ourselves that we're grabbing the correct segment, we are going to print out the initial altitude. So now we're going to set that mission file get segment with the appropriate climb index to our new desired altitude, which is going to be about 2,800 meters. So I'm just going to copy that line, throw it down here, and we're going to assign it to that desired altitude. It should be noted that the .xx value in the next real class is a float and only a float. You can't pass it an integer, you can't pass it a string, it has to be a float. And just like the initial altitude, I'm going to go ahead and print out the desired altitude after we change it to ensure that it was in fact changed. So now it's time to run the computation, but before we do, we need to save the changes that we made to a new file so you don't overwrite the existing file. You can create a file name however you see fit, but I'm just going to append a modified indicator to the end of the existing file name. And when that's done, we're going to utilize the save to file class method of the mission file class to save our new file. To run the computation, we're going to need the path to the APP7 executable and the mission module from the pyAPP7 package. So I'm going to go ahead and copy my APP7 directory here, and I'm going to add the mission module to the list of modules I'm importing from pyAPP7. With this, we can instantiate the mission computation class and pass it the APP7 directory. To run the mission computation, all you have to do is access the method run from the mission computation. And as long as you pass it the correct and new mission path, it is going to run successfully. Now, the run method is going to return a true or a false. So I'm going to go ahead and throw this in an if statement that's going to print a success or fail if I get a true or if I get a false. The results of the run are stored in the mission computation class. For brevity, I'm going to store the results in a new variable, results. Unfortunately, just like the segment list, the index of the desired results variable is very important and not as obvious to find. Thankfully, pyAPP provides a getVariableIndex method as a part of the results class that returns the index of the provided variable name. Although, the variable name passed must match exactly with what the method is expecting, so spelling and case matters. With these indices, we can then loop through the results segment list and grab the desired variables. In this case, I'm going to grab and plot the altitude and time over the course of a mission profile. So as you can see, I'm going to go ahead and import NumPy, and I'm going to instantiate two NumPy arrays, time and out. and I'm going to create a for loop over which I'm going to iterate the segment list. And with the previously gathered indices, I'm going to populate those NumPy arrays with the data. And to get the data, we're going to use the segment class method getData, which is going to return a list of lists of all of the data. And we're going to grab specifically the altitude index and the time index. And now I'm going to import matplotlib. I'm going to instantiate a subplot, and we're going to plot up the mission profile. And now it's ready to run. So if we move over to the console, we see that the initial altitude is the 2500 and the desired altitude is 2800. And moving up to the plot, it shows that our mission profile that ran starts out at sea level, goes up to the new 2800 cruise, and back down to landing. So that's just about going to do it for the pyAPP installation and mission file runs. In the next video, I'm going to go over performance file runs in pyAPP. I hope you all enjoyed. I will catch you in the next video. Bye-bye.